All right, everybody. Let me kick this off. While I think that's the only way to speed this up. All right. Hey, everybody. Hey. I'm super excited to have you here. Thank you for joining. It's, I think, a very special moment to be in Figma, in one of those amazing Ruby success stories. And I think we'll learn more about it today. Of course, an amazing product built with the power and beauty of Ruby. We have a nice agenda today. But before we go into all of this, let me just share a few stories, a few updates. One of them is that on Saturday, we had this very cool, very successful hackathon organized by some folks here. I think it was a huge success. We should do it again. Yeah, Camille, I mean, you should do it again. Yeah, all right, something else. Oh, yeah, these are the judges that we had. It was a real hackathon with the judges, with the prizes. Between our previous meetup and this one, Chime actually IPO'd. Yay! So this is just the most recent proof that Ruby and Rails gets you from idea to IPO. Because Chime is the startup that started on Ruby and Rails and just IPO'd last month. Exciting story. But you know what? Figma filed for an IPO. It's actually a slide from my RailsConf talk, one of the slides. Yeah. There's another slide I want to share. This is a survey by a pragmatic engineer, and I'm sure many of you know this blog, and Ruby and Rails ended up on top five of most used languages, but what's even better is that it's top 3 most loved languages. So if you need to convince somebody, and I think you need to convince somebody to create a Ruby SDK, create a library, support Ruby, invest in the ecosystem, just use this as a reference. I'm serious. It's a very amazing source of knowledge that lots of engineers and engineering managers read and trust. What else? There's something else. Yeah, okay, we're a few minutes in, 6 minutes, okay. And we actually just launched the general ticket sales for the San Francisco Ruby conference. Whew. So again, I know I talked about this conference already, but this is just an incredible story happening, that is happening thanks to all of you, that we are bringing back the Ruby conference in San Francisco, in the heart of entrepreneurship, where I think Ruby really belongs. So we just launched the ticket sales, general admission ticket sales 6 minutes ago. Seriously? We also just completed the CFP review. So we just reviewed all the talk proposals. I just pushed to main 4 minutes ago. I pushed extra 11 speakers. Not everybody confirmed yet, but we'll be adding a few more speakers. But basically, we have almost the full list of speakers on the website, sfruby.com. Go check it out. And also, yeah, come and get a ticket for yourself. So yeah, thanks a lot. And we'll hear from a few of those speakers, Jeremy and Marco tonight. But let's first hear from this amazing Ruby team at Figma. It's a great team, but we'll hear from Mike first. Yeah, so Mike, take it away. Not Mike.
Yeah. Cool. Hey everyone. My name's Mike. I'm an engineer on the billing team. Just want to say welcome to Figma. Happy to have everyone here, host y'all. And thanks to Irina for making all this happen. I think we started talking about a year ago to see if Figma could host the event. Thanks for your patience. I'm glad we were able to finally pull it off. Ruby's been a super important part for Figma's journey over the years. That's been true basically since the company was founded. It's a core part of our development stack. And I think historically we just haven't really talked a lot about how we're using Ruby. So happy to be hosting y'all here, start sharing a little bit more about what we're up to. So yeah, Kim is going to talk a little bit more about our Ruby stack at Figma. And then Harrison, another one of our colleagues, is going to talk about a tool we've built called Hennessy that lets us build internal tools with just Ruby. So thank you all. Thanks for being here. Yeah, welcome, Kim.
Thanks, Mike. Hi, everyone. I'm Kim. I work on our application platform team, and we manage the Ruby monolith at Figma. So Ruby upgrades, dependency upgrades, scaling, async jobs, feature flags, anything that goes into the monolith, we take care of. It's a lot of fun. So I'm going to do a very brief tour of that stack. It's a little bit unorthodox, but I think it goes to show just how cool Ruby can be. You can sort of pave your own path. First of all, we run Sinatra. About 2,000 routes power the main Figma API. And inside Sinatra, we have active record, which is a little bit unusual, but it works great for us. A lot of the writes in Figma happen through our live graph system, which is this live GraphQL-esque thing, but all of the writes go through to Sinatra and active record. Underneath active record, we have a system called DB proxy that is a layer between active record and the database. It allows us to do sharding in all possible directions, plus a little bit of safety things like load shedding traffic when needed. You can read more about it on our blog. It's pretty interesting. Tests are really important. We use Minitest, and we have a bunch of unit style tests and a bunch of spec style tests, and we're trying to agree on which one is the proper way, and maybe we'll do a talk in a year when we have figured out which one will win out. We also run a lot of async jobs on a custom written async job processor. These are like smaller, quicker style async jobs. We have a lot of concurrency controls, safety guards around it. For larger workflows, we use temporal through, I think, the Coinbase gem, which is pretty cool. And another thing we rely on is sorbet. We have sorbet about 98% of our code base, and 75%, I think, of that is strict level. So we really rely on it. It's really important for safety and good editor integration. And we like it so much that we've written a little layer we like to call typed routes, which allow us to type check incoming and outgoing HTTP requests and actually give us sorbet types for our params object, which is super neat. And we are trying to integrate it with the front end so that we can share types between the front end and the back end. I'm also going to talk a little bit about modularizing the monolith, which is an interesting topic. It turns out that engineers want some form of organization given to them. And our code base started with Sinatra. And so we don't have Zeitwerk. We don't have auto loading. So we are trying to fix this. We are Zeitworkifying our entire code base to get rid of all these require statements, which turn out they're really hard to deal with. And especially, we have a lot of engineers who don't work on Ruby every day. And so getting rid of these little paper cuts is really important for us. Another thing we're trying out is pack work. We're trying to really break our code base down into these smaller packages. It's really hard. And it turns out that there are like twice as many ways and opinions to do it as there are engineers working on it. And we are currently trying probably to do public-private distinction and no active record across the boundary. Maybe we'll do another talk in a year when we'll tell you where we actually ended up. But one thing we really enjoy is hearing from all of you how you have tackled this problem, because, I don't know, I find it really interesting. Lastly, if any of this sounds interesting, we are hiring. Thank you. All right, Harrison.
Thank you, Kim. Definitely appreciate that. And always cool to see all the Ruby projects happening at Figma, because the company really likes to talk about the multiplayer game engine that powers Figma, and that's obviously in C++ and all sorts of other technologies, but it's really cool to see the Ruby technology that also really makes Figma possible. So yeah, thank you again. Okay, so my part of this talk is to talk about how Figma builds admin tools. Okay, my name is Harrison. I'm an engineer on the internal tools team, and gonna talk about how Figma builds admin tools. So I'm gonna start with a quick intro to what my team does, then talk about admin tools at Figma, the framework we're working on to build admin tools, and go through a few examples as well. So this is the internal tools team. Our mission is to solve tooling challenges at Figma. So the remit of the team is pretty broad, but for the purposes of this talk, I'm going to talk about the Sinatra application that we have for building admin tools. So as you can probably tell, you're actually looking at the admin tool application. This is our staging version of it. This is the main application that administers Figma.com. Actually, let me bump the font a little bit. This is not my laptop. How do you bump the font, Kim? Sorry. Swedish keyboard? Oh, God.
Let's see if that works.
Oh, minus?
Yeah. Yeah.
Oh, okay. Yeah, minus is minimize in the US layout. Interesting. Thank you. Yeah, so this is the main application for administering Figma.com. It's written in Sinatra and React, and this is where Figma developers build admin tools. So some of the use cases this application has are sales tools for looking up customer data, finance tools for issuing refunds and invoices, support tools to do miscellaneous administration of customer accounts, and all sorts of developer tools. So the main problem that the internal tools team is trying to tackle when we think about admin tools is building tools is pretty time consuming and cumbersome. And if you're a developer, all you really care about is how do I further my domain or area of responsibility? And you want tools that are robust and powerful to use for that end, but you want to make them with as minimal friction as possible. So in kind of this standard Sinatra React example, you have to scaffold a bunch of controllers, make React components, design the UX just right in order to meet your use case. And anything we can do to minimize that friction and make that as streamlined as possible ultimately improves the quality and functionality of the tooling, but reduces technical debt and risk. So to pursue this goal, we are working on a framework called Open Trust. It's an open source framework for building admin tools. It's maintained by the internal tools team and friends we have at GitHub, who also use this framework internally. Open Trust has this concept of panels, which are the declarative representation of an admin tool. They have the data, the logic, and the display all encapsulated in one chunk of code, which makes it really easy to build tools and maintain long-term. So I'm going to quickly walk through the architecture of how this all works and then go through some code examples as well. So at a high level, the architecture is there's a Ruby DSL that generates YAML, which then we send up to the client. And there's a rendering engine in the browser that knows how to take that YAML, or JSON in this case, instruction set and transform it into functioning compiling React code. So to go through a really quick example, this is a really simple panel that just grabs the first user from the database and renders their name. So let's look at the source code. So this is the source code of that panel. And here you see the anatomy of a panel. So you have the octagroup declaration that says who is allowed to use this tool. Then you have the main entry point, which is the render function. In here, you have a note that's being generated, which is the blue banner, and then a markdown block, which takes just arbitrary bit of string text, and in this case has the name of the first user in the database. So the first user in the database is LuoG, apparently, in staging. Shout out to those who get that reference. So as you can see, really simple DSL. And everything, importantly, is all in Ruby land. So it has access to all the data and Ruby models that you need to compile and build your admin tool. And there are no new controllers or APIs needed, and no scaffolding of all that that's necessary. And URLs are generated automatically, so none of that boilerplate code. And if you need to import panels in different locations, you can use this React component we made to import panels. And you can also have panels imports other panels. As you can probably tell, oh, maybe you can't because the URL bar is not here, but this whole presentation is actually an admin panel itself. And inside this panel, I'm importing this hello user panel as well. So it really supports a nice amount of composability to reuse existing tools that other developers have built. So go to a little more complicated example. So this is how we handle forms in OpenTrust. So in this case, this is just a simple text field. And when you hit submit, it's going to just render a flash message that says hello. So looking at this source code, it's very similar anatomy. You have just a form declaration here and the associated block of code that resolves that form submission. In this case, it just calls flash and renders the text. So again, really simple DSL. As you can see, just plain old Ruby methods and classes, and really easy for our developers to use, which is critically important because as much as Ruby is near and dear to our heart, most Figma developers actually don't know how to write Ruby, and they're pretty new to the language, which makes it all the more important that the friction be as minimal as possible to write admin code. All the more so React. Developers at Figma have even less knowledge of how to write React. And as you all probably have React experience, writing React can be really, really toilsome. And last example that's going to be, a little more involved. So tables are a pretty important primitive we have inside of admin tooling. So very useful data structure. So this is a simple table where you can just filter on arbitrary values. We support the ability to do row operations on your table, multi-select, kind of everything you would expect a UI experience to have, table aggregations, et cetera. So looking at the code here, you can just see the resource being declared here. It's just an arbitrary list of cats or dogs, the columns that the table is exposing, multi-select options for the table selections, and a table action to perform the operation on the table. And that just takes another panel itself. So the rows you selected are just passed to this other panel, and that knows how to, in this case, render a modal and also do a flash for those rows. So pretty compact code, all kind of beneath 50 lines of Ruby or so. And React corollary of this we've tried is definitely a couple hundred lines of code. So anytime we have a smaller footprint, the better, because code is liability, as it were. So I don't have enough time to go through the full DSL and all the features, but that kind of gives you a sense for how we build admin tools at Figma. And there's kind of much more to it, but that's maybe for another talk in the future, to borrow a line from my colleague, Kim. So at a high level, you can kind of tell the design principle we have here. We're really trading some of the power and flexibility React has for much greater developer speed and reliability of tooling and utility ultimately. And we think for admin tooling, this is kind of a sufficient trade-off for 95% of use cases. And we support the ability to kind of escape hatch into React as necessary. And ultimately, this is going to be something that gives our developers more velocity for making tools. And the more tools we have to make admin a better experience, the more we can kind of administer Figma.com and ultimately service customers. I think I'm running short on time, so I'll kind of skip a lot of these details here, but we'll end the talk with some cool examples. So these are a bunch of panels that I just imported that are floating out in the wild of admin that I just imported right into this presentation. So one of our new hires made a Garfield questionnaire. Raise your hand if you know what Garfield is here. All right, Garfield fans. What is Garfield's favorite food, if anyone knows? All right, let's put in lasagna. All right, lasagna, everyone got their answer right. Good job. All right, this is a panel to look up a user's plan. Can look up by, I think, the user ID. Nothing too special about this panel, but it's more just want to show the UX of selecting a drop-down, a bunch of different options, and then you can kind of curate an experience and guide the user through a different set of flows. This is a random tool for just managing webhooks. This doesn't really work on staging right now, but I wanted to highlight a pattern we've seen being used, which is rendering nice instructions for the users of your tools. Good documentation is very important, especially for admin tools, and it just shows having that empathy for your users is really important, particularly for support users. I know it's really easy for us to build tools in the mindset developers are using them, but oftentimes a lot of non-technical people will be using those tools. This is a panel for submitting a bug report. As you probably have seen, there's this kind of toolbar that's sitting on every single admin tool. We have the ability to render a bug report right here for that particular tool. And when you submit that, it gets routed to the team that owns that tool and their particular project board. Another tool is adding seats to a customer's plan. This is a tool that Mike's team built because it's a billing tool. Shows you how many seats they have, and you can kind of just add seats. And I like this panel because it's pretty cool, like the amount of UX and aesthetics you can imbue in this admin tool, even though this is all in Ruby. That's just being declared, which is pretty cool. Then we have this panel that renders Datadog dashboards. It's kind of a nice thing to have for developers to embed a Datadog dashboard of whatever metrics are relevant to the tool they're working on, which makes it much easier to co-locate various tools for the experience of using an admin tool. And we have plans to do many more embeds as well. And I'll end the talk with this fun little tool we made, which is the game of Snake. So we were doing a bunch of experiments to see how good AI is at making open trust tools. Our theory was that because the framework is so highly typed and structured with a lot of metadata, that it's a really good use case for AI to understand actually how to build these tools. And we experimented this with the game of Snake. We asked it to make an ASCII version of the game of Snake. And lo and behold, it was pretty much able to do it with just a minimal amount of bugs at the end that we just tweaked. And we kind of just left it as is to show what AI could do. Obviously, you would design a better version of Snake than this, but you can see it actually work. You probably wouldn't want to do full HTTP requests for every single game move. But you know, here we are. AI can do magical things. And if you don't know what the game of Snake is, you're a snake and you're, in this case, trying to eat an apple, basically. Oh, and I think I just lost. I hit my tail. That's how you not play Snake. Don't hit your tail. Yeah, and with that, that's pretty much the end of this talk. Thank you very much for listening. And I think there's a short Q&A session for Kim and I if there's any questions from the audience.
So it sounds like instead of initializing a Rails stack, you're creating little lightweight apps. And how do you go? All right, hey everybody. So since you don't have to initialize the whole Rails stack, you just have little, I mean, the kind of like servlets. I mean, people could call them little services. How do you find that now you scale your, I mean, maybe your web server? What kind of configuration changes do you have as opposed to running a Rails stack? It seems like you have a bunch of little connections that come up and die, but you know, what's the advantage over just having a big Rails stack with a bunch of threads or whatever connecting?
Yeah, I think Kim should answer this one, but I will also say this is for just the internal admin tooling for what it's worth. So it's not for public-facing pages. So Kim, you want to answer the rest of that question?
Yeah, I can talk a little bit about the Sinatra part. We run Sinatra in Unicorn, so it's like works just like a Rails server. All the routes are just like those like route blocks that you have in Sinatra, and it is maybe a little bit tricky to organize at this scale, and that is something we are thinking about. So it works really well, like early on, you can do stuff very fast, but at scale, the organization becomes a little bit tricky.
Okay, I have to ask very quickly this follow-up question. Did you consider Roda? Because we have the author of Roda here.
Well, I was not here when we chose Sinatra, but I would surely have chosen Roda.
And that was the right answer.
I'm curious what your onboarding process looks like for new engineers. Like, how do you teach them the DSL of your framework, and then how long does it take to become productive?
That's a really great question. So we're in the process right now of making an onboarding session for this. And what you saw from my esteemed colleague who made the Garfield Q&A, that was kind of a guinea pig for that process. And they said they found it quite easy because the footprint of the DSL is pretty light and it's pretty intuitive, especially when you compare it to React and having to understand how to scaffold that all up. And also, as a new engineer, how to make controllers and routes inside of Figma. Everything you need to render this is literally that snippet of Ruby. Like this is just kind of one Ruby class you have to declare and it has everything you need. And the onboarding experience, I think, is just a lot smoother than alternatively.
I saw in some of your types you have like you're returning some kind of an action something or other. What's the use case for having just a void action versus a return type? Does it, when it invokes the action, does it do something different depending on that, or?
You mean the render right here, that's a void?
Yeah, sorry, I thought maybe I saw a different signature that returned something, but maybe I hallucinated that.
Oh yeah, all the form actions basically have
okay.
return types, yeah.
Gotcha.
Not sure if folks here are familiar with video game programming, but this is kind of a similar paradigm to that, where you're doing render operations on every game frame, and you kind of buffer the response, and that's kind of the pattern we're doing here. Every time a developer calls one of these bang methods, they're interacting with the frame buffer and adding UI components, essentially, that we then send up to the browser, if that's a helpful analogy at all.
Okay, looks like no more questions at this point. All right, nice. Okay, you can, folks, you can grab these 3 guys over here during the break. But yeah, thank you guys, amazing presentation. Yeah. Yeah, I think this approach is really neat. It's kind of nice. Yeah, I like it, and it kind of is a great segue to our next topic, where we're gonna talk about the front-end story for Rails, and also the vision for the front-end story. And yeah, our next speaker really doesn't need an introduction. This is Marco Roth, fresh from after, he's here after RailsConf. And yeah, let's hear what Marco envisions for the future of front-end in Rails.
All right, thank you so much. Yeah, today I want to talk about the modern view layer that Rails deserves, in my opinion. So it's kind of like a vision of what we have today and where we could go if we kind of chose to build out these tools that I'll talk about them today. So yeah, my name is Marco. I am an open source contributor and full stack engineer. And I love open source. That's been my go-to. It's so fun to kind of work on these tools, and it's so inspiring to me to just build these tools and help give back to the community that has been giving me so much over the years. I have been on the core teams of Stimulus Reflex and Cable Ready, which are kind of predecessor to Hotwire that we know today. And I've been on and off maintaining the Stimulus library as well. But today I want to talk more a bit about an adjacent topic, which is the Rails view layer, and more specifically Action View. So Action View was introduced in 2005 in July 2004, and even back then it was kind of the part that made Rails MVC. So it was Action Pack, which was responsible for the controller and the view. And even then it was ERB, which is embedded Ruby. And pretty much what this is, which is still today, it's templates that are plain text files, which have some sprinkles of Ruby embeddings to render out a text or a string in the end. And I wanted to talk a bit about kind of the history, how that kind of evolved over the years. So in Rails 1, we got layouts and partials, which we still use today and are still very useful. And Rails 2 introduced this HTML ERB file ending, which kind of replaced the RHTML we had before. In 2010, with Rails 3, we got the automatic HTML escaping. So before that, you had to use this helper to kind of render out user-provided content to the view. With Rails 3, we also got the Action View templates, which is kind of an abstraction on top of the template handlers in Rails on Action View. So it kind of is one interface for ERB, for Bundler, for Haml, for Slim, all the languages you can think of. This was also kind of brought back from the MERB framework that kind of was merged into Rails with Rails 3.0. With Rails 4.1, we got Action View variants, which are, if you're not familiar, you can have different versions of the same view for like a mobile version or a regular version of that same view. With Rails 5.1, we got Form With, which is still a useful help of use today. And for Rails 6.1 in 2020, we got a super interesting concept, which was probably the most different approach to how we would do view components in Action View. But this didn't end up being merged. It was in one of the betas, but it was later extracted as view component. So Joel Hawksley talked about this in his RailsConf talk a few years ago, and it's a really interesting talk where he goes into why he built that for GitHub and how they were struggling with building out views and scaling views. And if you haven't seen this talk, it's really a big recommendation. Even though we didn't get view components into Rails, we got this render-in API, which allows any third-party component framework to be rendered using the render method in Rails. With Rails 7, we got Hotwire by default, which is not strictly Action View, but it's kind of important in that timeline. And then most recently, we got partial strict locals with Rails 7.1, which is kind of like a method signature for your partials. So you can define the locals on top of your view file or your partial, and then it has some signature to the partial. But yeah, kind of if you look at this from a public point of view, public API point of view, this has been really stable. There hasn't been too many changes, and most of them were really just additive, which is kind of nice because it makes it really easy to build on. And like for the long term of Rails, this has been hasn't been changing at all. So a view after I have written 10 years ago probably still works today. But over the years, there has been many different approaches on how you can approach the front end, how you can make it interactive, how you can build the front end in Rails. So it always has been about this server-side rendered HTML. And that's not going to change in the future, I think. And also means that ERB isn't going anywhere. To me personally, it's probably as pure as it gets if it comes to HTML templating, because you just get to use the HTML tags, you have some Ruby sprinkles, and that's how you organize your view files. No specific specific language or syntax that you have to learn to just render out HTML. But this also means that the HTML tooling gets more and more important as we kind of build up on top of this approach. And now with Rails 7, we got hot wire by default, which means that we kind of try to build more on that whole approach of using HTML on the back end. If you look at the survey from last year, which is the Rails developer survey, we can also see that Stimulus has kind of rose up to the top 1 spot. And we see this also in the wider web community, that we kind of try to go back to more simplistic approaches when it comes to building applications. So here's the State of JS survey from last year too, and you can see at the bottom here, it's slowly gaining more traction. This is Alpine.js, which is similar to Stimulus. And more recently, we also see this rise up of HTMX, which is similar to Turbo. So yeah, it's pretty much this server-side rendered HTML that's getting more and more important again, which also means that we have more HTML templating that we kind of handle with. But this doesn't come without its issues, and there are some that we have been trying to solve over the years. Here I try to list some, especially the encapsulation and view boundaries or usability are kind of solved with view components, performance in a way with the caching. You have some of these built-in tools in Rails, but it's not really a good story. The tooling has been lacking. If you kind of compare this to a regular JSX file or a TSX file, there's nowhere near that experience. And like this testing approach in just with regular view files or partials without having to spin up a whole system test has not been talked about too. But that's kind of what this talk is about. I want to talk a bit about the vision of how that could be and what we have today. So this is kind of first up is developer tooling. One thing I always liked about the Rails screen or the Rails experience is that you always get this nice interactive exception message or screen. You can see where the error happened. You have a interactive console. You can see the variables. You can see the call stacks. You can interact with this. It's really nice. And if you look in the wider web community, you also see that other frameworks are still looking up to this, and because they don't really have anything like it in other frameworks. But if you try to use this with ERB files and have a syntax error here, it's not as easy as it is with regular Ruby files. Obviously, in this example here, we have a missing closing tag right here. There has been some improvements to try to make this better, but it's still not to the point where it's really nice to use. But if you look into out of the wider web ecosystem, you can see that in JavaScript, the developer experience is really awesome. One example here I have is Vite, the bundler. If you have an HTML file in Vite.js, it will kind of show you where the error is in your view file. And Vite kind of shows this whole developer experience, how far it can take it. And it really shows a really nice workflow of how you can go from like the view framework to like the bundler, to the testing framework, to documentation. It's a very like awesome experience all the way through. And people coming from these frameworks or these other like languages expect these tools to be there when they kind of switch over to Rails or use Rails. And that's something I believe that new programming languages have to have in mind when you start a new language today, that this should just be built in the way it works. And yes, we could make fun of JavaScript now and say how fast the cycles are and how fast and bad this is. But I think we can learn from these tools and kind of bring some of these ideas back to Rails. And I don't want to give too much credit to the JavaScript ecosystem, but I think that the view layer, the components, the developer experience, and the tooling, they really nailed that part. And coming into Rails and kind of using Rails, I think that's the Ruby ecosystem, even at a greater scale, all the gems really worked well together. You just use this gem and this other gem, and they had some integration, and it was just plug and play. They would just work. And in the context of Rails now, I think that we have also a similar story that we could have with the view layer to make this more plug and play and just easy to use. If you open or use any editor today and open any of these kind of JavaScript files, you get instant feedback, instant diagnostics, you get all the language tools built in. You don't have to install anything for it to just work. So they have a great out-of-the-box experience, it just works. But how does it compare to Ruby? Over the last decade, if you kind of open a Ruby file in any of your editor, you would get mixed experiences depending on which editor you were using. But luckily, this is changing with Ruby LSP more and more now, which is also now the recommended way in VS Code to write Ruby files. It's pretty much a one-click installation, and you get a great experience out of the box. But this still doesn't kind of handle the HTML ERB files, which are still a different story. And that's what I've been trying to focus on over the last few years to kind of improve the hotwire tooling and the view tooling in Ruby in the Rails ecosystems. So I initially started with the Stimulus LSP, which just gives you some helpful diagnostics when you work with Stimulus code. And then I was trying to make this also work with Turbo, so you get more feedback when you work with Turbo. So here's an example. If you have a Stimulus controller and you kind of use any of the identifier, it will tell you and know about all the controls you have and will tell you that something is wrong about it. It also helps with autocompletes, so you get all the actions that are possible, and if you kind of define an invalid one, it will tell you that. But none of this had like ERB support. This just worked on HTML, on raw HTML. But it's quite common for Ruby apps to use these action view ERB helpers. So what looks like this now in HTML could also, in the most extreme case, look like this in any view file. And you would get no tooling, and it would just kind of be a blind spot in your tooling. And Action View itself didn't have any tooling over the years too, so it's pretty much been the standard. You didn't expect for it to have tooling. But having worked on these adjacent tools, I kind of was thinking that there's something is missing, and that's why I wanted to tackle the bigger picture. And this is also where this new project comes in, which is called Herb. So Herb is kind of an ecosystem for HTML ERB files to help you write better tools in your day-to-day job. Initially, it was set out to be a parser, a formatter, and a linter for HTML ERB files. But as I have been building this out, it kind of expanded into a lot more of these tools that are needed to make this a nice experience. First, the parser. This was back in April at Ruby Kaigi earlier this year, where I was talking about this, where I introduced this. And if you want to learn more about how the parser works specifically, I would highly recommend to check out this talk. But TLDR is, it's a new HTML-aware ERB parser. It's written in C. It's built using the Ruby Prism parser to parse the individual Ruby snippets in your ERB files. It's designed for tooling, and it has support for all the action view helpers. And what it gives you is kind of a syntax tree which has the HTML and Ruby interleaved in one tree. So this gives us structural awareness of these files and gives us the possibility to build tooling on top of it now. And you can ask why we don't use Nokogiri and Prism, which are really good at parsing HTML and Ruby respectively. So if you look at this example here, we have a pretty basic Ruby ERB file. And we could say we split this up into two individual pieces. So we have the Ruby on the right side and the HTML on the left. And we would extract the Ruby parts from the HTML file and the other way around. So we're just left with a Ruby snippet and the HTML snippets. And now we could use this and pass it to Prism and Nokogiri, and we could parse it, and we would get back some results. But what we did in this process now is we lost the whole context of where you are interpolating these snippets in your file. So we would need to piece these results together again, which also doesn't allow for any of the handling edge cases of what happens when something doesn't go right. One example here I want to kind of highlight is this snippet here. So what you see here is like a Ruby ERB tag, some HTML in the middle, and a ERB tag at the end. But the thing is that we would have to know that this if tag is opening the tag, or this like context, and the end one at the bottom is kind of closing that whole if context. And this H1 is kind of a children of this whole operation, or this whole tree. And that's what kind of Herb is giving us now. So what we have is the initial opening tag for this ERB if node now in the syntax tree. So we have the opening tag. At the bottom, we have the closing tag. And these two together form this ERB if node that is just containing this H1 tag with its children of it. So this just gives us the hierarchy that we need to be able to build tools around it. And if you compare this to this other approach where we kind of split it apart, we wouldn't know that this Ruby snippet right there is part or children of this span or this B tag here. But this opens a lot of doors for us to be more, strategic about building more of these tools for working with HTML files. So that's why I want to talk about this formatter now, which we have released the first preview. And the idea here is that this is a HTML ERB auto formatter, which you can just give it any randomly formatted Ruby snippet ERB file. And if you either save in your editor or you run the CLI, you get a nicely formatted ERB snippet back. This kind of also allows you to integrate in your editor workflows or in CI builds to make sure that all the files are well formatted. And here's a short demo of how it works in your editor. You save the file, and it kind of just snaps right in. If you go and update the file, indent it more, and then save it again, it snaps right back as you kind of expect. Thank you. Then next up is the linter. So we wanted to have more style guides for how you write HTML EV files. In the bigger Ruby ecosystem, we have the Ruby style guides, which are style guides on how you write good Ruby codes, and Rubocop and Standard are kind of enforcing that in with linters. But you don't really have a similar thing for view files. And this should be kind of a way to help people write better view files, kind of enforce these best practices and avoid these common mistakes. So what you get here is also, right in your editor, you get this integration of common HTML mistakes you can find. It also works for ERB code to kind of have a bunch of rules. It's just a beginning now, so we have only like 10 rules for now, but we have a lot more that we want to build out. A few of them are also kind of related to accessibility, which I think is something that is kind of getting more and more important, but we don't really have any tools, and especially not for HTML ERB files. But what we kind of get here is some rules that help us write more accessible view files. In this case here, this area hidden is kind of, there's nothing in this H1 tag now, and an H1 tag is always meant to have some content in it. But this is what the linter now understands, and since Herb can also analyze the view helpers from action view, it kind of works across these both of them. So even if you would use a content tag or tag that span, it would kind of work the same way. So a lot of these are kind of semantic, but it also have some stylistic rules. In this example here, if you don't add white space around these tags, it will kind of tell you. And the other nice thing that we have here is if you click on this link here, it will open the documentation. It will show you why this rule exists, why it's important. It will give you some examples on how to write this rule or make it good or bad. And then for the bad part, we also run our own linter now over these examples and show you right away what's wrong and where it's wrong in the view file, and kind of show the right message below it. So it should be easier for people to understand why this rule is there and what it enforces. So yeah, if you have any ideas for lint rules that we can implement, please open an issue. We'd be happy to take a look at implementing that. So this has been, thank you. This is all in the editor for now, but we also have a nice CLI, which might be hard to see here. But it kind of shows you where something is wrong about the file. It would highlight what is wrong and the message up top. And at the end of the run, you also see one summary of all the lint rules you violated, and yeah, summary at the bottom here. If you have a bunch of failures, there's also a simple flag you can pass it, so it's more easy to kind of look over if you have a bunch of errors. And then the other thing that was, when I was trying to build out this linter, I was looking for a HTML ERB syntax highlighter, because you want to syntax highlight these snippets. And I was looking for packages online, and it was like, there's nothing really good for making this work. And then I realized that I just built a parser and a whole tool set. So I actually should be the one who knows how to now syntax highlight these snippets. And that's what this package is for. So you can syntax highlight snippets in the console. Another nice thing that kind of came out was this rewriter. So this is just a set of rules for you to be able to refactor some tags, refactor some attribute names, and refactor some attribute values with some very simple rules you can define, and we'll just kind of run this over all your files. One kind of nice thing that we have in the, I guess, in the Tailwind community is this prettier plugin for Tailwind classes. And it will kind of sort these classes based on some logic on where you should put them, so they're always in the same order. And that's something we could now build with this to reformat these both of these syntaxes for the action view tag helpers, but also for the regular HTML tags. And that's the kind of tools we now can build using these foundations. But that's the other thing. It gives us the confidence now to refactor these view files that we didn't have before, because before you could just kind of search and replace. Right. And then one final thing we have is the Herb printer. The idea here is that when you parse a document, you get a syntax tree back. You can kind of mutate this or just have it somehow, like modify this. And then you want to have this be kind of printed back to source code. So the printer kind of takes this AST and produces a string again, so you can format or reformat these files. And this is going to be really very useful if you want to implement the autocorrect for these linters or linter rules. And then finally, the Herb language server, which is a plugin for any editor that supports the language server protocol. We have a few now here. There's some more we try to support. But the idea here is that you can just use the parser, the linter, the formatter, all in your editor, and it will just give you instant feedback. It will tell you about missing closing tags, missing opening tags, syntax errors, and a lot more. And the nice thing here is also, because it's using Prism under the hood, it will also tell you if something is wrong about your Ruby in your ERB file. So in this case, you're missing some arguments to this if, the condition for this if here. And then specifically for VS Code, we have some extensions too. There's like a dedicated syntax settings page. And it will also give you this nice little progress bar at the bottom of the editor. And it has this nice little sidebar where it analyzes the whole project and gives you a summary of how the parser understood your project and where there are linter errors. If there's anything wrong or anything you got wrong, there's like a quick fix action. We can just open the issue with some added context in the from the view file. And there's a lot more things you can do. We can try to find unused views, unused partials. We could try to implement smarter jump to definition for render calls, and a few more things. And now, I guess I say finally again, but there's one more thing, which is the Herb language service, which is the idea that we want to integrate with other tools. So I was talking about the Stimulus LSP and the Ruby LSP earlier, and these tools were using something called a VS Code HTML language service, which just gives you some tools to work with HTML documents in VS Code or in any editor that supports the language server protocol. But now we have kind of provided this language service from Herb, which understands both the ERB and the HTML. So we can just swap these out and now get these tools that you've written for your HTML code also for your ERB code. Which means that in the future, we are able to just support this kind of syntax here too, where it will tell you that this control doesn't exist in your ERB helpers. This is not quite ready yet. I have a working branch locally, but this is going to be up soon too. But what I have now is the Herb 4, well, 04 release, which gives you the linter, the preview of the formatter, this improved VS Code extension, this improved language server, and some more bug fixes for the parser. And now I want to talk a bit more about the vision to make it more what it is of the future. So what we want to do is try to look at a ERB rendering engine. But it's important to me to say that this is a vision. If you want to kind of advance what we have today, we have to explore what's possible, even if that means that none of this is going to be viable in production or for production usage. So yeah, here we go. ERB rendering engine and ERB rendering engine. So what we have today is a string template engine, if you will. But what we really want in the end is a HTML templating language or engine. An engine that cannot produce invalid HTML. Looking around in the ecosystem, we have some other tools that have been trying to make this nicer in the ecosystems. But one that sticks out to me is the Phoenix Live View framework, which is powered by Elixir. And Elixir has this language called EEX, which is kind of similar to embedded Ruby, what we have in Ruby world. But what they have is this format called HEEX, or HTML and EEX, but we don't have something like this in Ruby. So the idea here is that we kind of can try to build a HTML and ERB engine that knows and understands both HTML and ERB. If you look at ERB today, if you look or use this example here, we have a missing H1 tag here. And in this case, I'm just using the action view templates to try to compile this template using action view. So compile it using this handler call, and it will give you this safe append buffer output string, which just concatenates all these strings. But it doesn't tell you that something is wrong about this partial. It just kind of renders it out. It just does it. So the idea here is instead of using that we have something more advanced that looks at the structure of your view files, and when you try to render it, in this case using the herb handler, and try to compile it now, that it will crash and tell you that you have a missing opening tag that it wasn't closed. So it wouldn't even compile the template if there's something wrong with the view itself. There's another thing we can do with this now, where we try to make it more advanced, like reactive templates, which is similar to what we have in Phoenix Live View with these HEEX templates. The idea here is that when we have a view file or view templates, that we can look at a state. In this case, it's just all the instance variables from your controller. And I don't actually know how we would do this at this point, but somehow this value changes. We get a callback that this changes, which means the state changed, and we now try to just reflect this state change in the view. So what we know is that items changed, so we can look in our view file to see where we are using items, and now we can just say, let's try to only re-render the part that actually changed. So we only render out this li with the value of 4. And since we know about this whole partial and how it kind of is structured, we also know how to update it on the front end. So this would kind of just insert that at the right location, just as you would expect. You can kind of think of this as turbo streams that get emitted from the engine directly without you having to say, please render this specific snippet and insert it here with this ID, which then kind of just do it or know how to do it in the engine itself. And I was saying earlier, ERB is kind of here to stay, and Action View is also here to stay in Rails. But the idea is that we kind of want to level this up while keeping it still Railsy. And that's kind of this vision of reaction view that I want to kind of show you today. So what kind of HEEX is for Phoenix Live View, Herb could be for Rails reaction view. And the first kind of level that we have is, so I want to kind of structure this in multiple levels. And we can implement as many of these levels as we want, because it gets more advanced towards the end. But the first level is to just get better feedback. And I come back to this screen here from earlier, where we can look into, take inspiration from Vite and just render this error page with some helpful messages of what went wrong in your view file. This is just the first level, and then if we take it a step further, we can say, let's actually implement this HTML-aware engine. So we take it from a string template engine to a HTML templating engine. This would be fully backwards compatible, or at least you would try to, as long as you have already valid HTML files or ERB files. And this would then also raise these errors when you try to actually compile them, so it wouldn't actually be able to use any invalid view templates. And this is just for HTML validity, but we could also do more and check for valid HTML5. We could check for more accessibility things. We could check for XSS vulnerabilities, that you cannot do any unsafe interpolation in your view files, or try to do more advanced things like only use one ID in your view. These wouldn't block to render the end. These wouldn't block for the engine to render it, but we can still detect that and show you a helpful message that something was detected in the template that wasn't quite right. A third level could be that we look at how we can make Action View more optimized. And this has to do with how we compile these templates. There was a good talk at RailsConf last week by Hartley. He was talking about the Action View cache, but also how we can compile these templates. And there's some interesting work by John Hawthorne with this Action View precompiler, where he precompiles all these templates on boot, so it's more efficient when you try to fork the server. But these are just ideas. I'm not sure how feasible they are, but one of them could be that we say that we try to rewrite these partial calls to just make them inline. So we inline these calls directly, so it is only one view. So it doesn't have to do this render call at runtime. There's probably more things we can do, but this is just the ideas. Level 4 would be that we integrate these reactive templates, like this here, that we have this all built in. And one way I was thinking about is that we can say we have this HTML ERB, and what we could do to make this opt-in, that we just rename this one file, and by renaming this, you opt into this new stricter engine and have these benefits built in. This will allow us to make this more progressive, so it doesn't have to be an all-at-once migration. You can gradually adopt this, only the view that makes sense for using this. And it doesn't have to be all or nothing. It's just where it makes sense, you use that and just make it reactive. And just by this simple rename, we can make this a lot easier. But it would also allow us to introduce new syntax technically if we really want to. I'm not saying we should, but there are some interesting ideas from Cameron with his Rux framework, which is like a JSX in Ruby. So it allows you to render these view components or any of the components in a JSX style render syntax that you could just then use in your ERB files. Level 5 would be to try to reuse some of these ERB templates we have on the server side and bring them to the client side. Joel was also talking about this in his talk, where he was saying that we should only pass values, not full-blown active record objects, into our view components. So what I'm saying here is if we try to limit the set of valid ERB that you can use, we could do something very similar to what React did with React server components. So they brought the client components to the server side, but we could bring our ERB templates from the client, from the backend side to the client side. And we could try to either transpile them or rewrite them or do something with them that we can expose them as web components maybe, as React components, whatever. There's some way we can make this work. But it would allow us to bring some of these optimistic UI updates, so you don't have to do a full client-server request cycle for the smallest interactions. Maybe there's also opportunities to improve offline functionalities using service workers, and some more trivial, non-critical interactions on the client side by just having these available on the client side to do. And then finally, there's level 6, which would be trying to integrate external components. So you don't have to say, I want to abandon HTML ERB altogether, but I could say, I want to use these specific components in our view files. Again, here, this would also say that we can only use them on certain pages, which is kind of similar to trying what inertia Rails does, but with the difference that we can use and keep using HTML ERB. With inertia Rails, you have to return a whole JSON object from your Rails controller, and then it's kind of fully taken over by React. But what this would allow us to still say, we can use our ERB next to our components side by side. The idea here is that we try to kind of look at import maps Rails, how they kind of pin these dependencies. But instead of pinning dependencies, we would try to define which controls you want to use or which components you want to use from external packages or from our own application folder where we have our components defined in line. And I was saying earlier, this would allow us to build something like this where we have ERB, HTML, and then some of these client components right next to the view file. In this case, the engine would know which of these components are client-side and server-side and would know how to hydrate them and kind of render them on the client side when they kind of get to the client. This is also very similar to what Turbo Mount does, which allows to use any of these external frameworks too. But with the difference that this is tightly integrated with the engine, it has the built-in tooling, the editor tooling, and doesn't require any setup and just works out of the box. But then again, I just want to see what's possible. I want to kind of share how far we could go if you would implement all these 6 levels. I think even if it would just implement the first level, it would be kind of a big improvement. So yeah, what's next? Right now we have the formatter, the preview of the formatter. We want to improve that to make it more stable so it kind of works across more files. There's still some edge cases where it's overly aggressively formatting HTML ERB files, which is not quite what we want. We also want to make the linten formatter more configurable so you can kind of make it your way. And then finally, to kind of see how far we can take reaction view by implementing any or none of these levels. I have a talk later this year at Uruco where I want to at least release the first prototype of reaction view. I'm not sure how far I will get, but I just want to see what's possible. But yeah, to conclude, Prism itself, the Ruby parser, had a big effect on the greater Ruby ecosystem in terms of internals, but also on the tooling, which allows us to build tools like RubyLSP now. Rubocop is using it, and all of these tools are just getting better because we have a better parser. And I think we could have a similar effect for the HTML templating and tooling because of Herb. And the community itself has built a lot of awesome tools for Ruby itself. And for me, I think it's now the time to bring the same care to the view layer. And I believe that with Herb, we have the path forward to make this happen. In the end, I still love Ruby, and I want to keep writing Ruby, and that's why I want to keep it as attractive as possible for new people as well as for myself. And finally, I want to thank these people here on the slide, which have helped in some way or form to make Herb possible as it is today, as well as all the contributors to the Herb project directly in code contributions. You can check it out on herbtools.dev or give it a star on GitHub at markerov/herb. If you do me one favor, try to install Herb in your gem or in your project, run herb analyze, and it will tell you if you can handle any of the view files you have in your project. If you don't want to run it on the CLI, you can also use the, If you don't want to use the CLI, you can also use the VS Code extension, which gives you the sidebar and this summary in a more browsable way to see it visually. But yeah, that's what I have for today. Thank you so much.
That's quite a lot. I think folks, you had many people impressed at stage 2 and 3, and then you kind of kept going. All right, questions?
What's your plan to bring Herb to the non-Rails ecosystem?
Yeah, I think like the ERB engine itself could be used outside of Rails. That's the idea, that Herb itself as the engine can be used outside of Rails. But that reaction view is kind of the integration of Herb into Rails as the view layer. But I don't see why it wouldn't work in Hanami or any other low-level Ruby web framework.
What should we do if we find examples of files that Herb cannot analyze?
Open an issue on GitHub.
Great.
Yep, thank you.
Hi, I wanted to ask you if you're planning to support HAML and what are your thoughts about HAML?
There are some plans to make the tooling shared so that we have a shared, I want to say, syntax tree that maps from ERB to this shared tree, where you could also write a adapter for HAML. So if you have write tools like LSPs, it would kind of support all of that out of the box. I personally don't use HAML myself, so I have not a big interest in supporting it myself, but I don't want to kind of hold it back if somebody in the community wants to help build that out.
You were showing one of the examples earlier where you had the H1 tag and you're saying that like, oh, this is an accessibility violation because the tag doesn't have any content, and that's like the H1 tag should have content. And so that got me thinking like, have you ever thought of like could you use sorbet types or something to look at the type signature of this helper and see that, oh, sometimes it returns nil, so that'll mean this tag it could be sometimes empty. And then what are your thoughts about integrating like type checking into Herb?
Yeah, very good question. I have been thinking about this. I have some ideas about, I think I call them HTML shapes, how a view file returns a shape of how the view could look like. Like it could either render this element or that element based on a conditional. And that's going to be useful for the linter itself too, because as you said, depending on if we go this or the other path, it's going to affect what is being rendered. So there's some ideas that we want to have shapes, I think that's what I call them, in Herb too. Yeah, we can analyze and output that from any view file.
All right, so I don't see any more hands for the questions. All right, we'll go into the break now. Thank you, Marco. Again, let's do another round. We're gonna take 25 minutes, and after the break, we have our traditional open mic. So prepare your announcements, questions, anything you want to share for the open mic. I'm sure people here are not shy to take the mic, right? Nobody's shy. Nobody. Yeah, talk to folks from Figma, and yeah, see you in 25. All right. Okay, I'll start with a little announcement myself. Oh no, not this one. Yeah, I'll start with a little announcement. We just need to be plugged back in. I know, got it. Sorry, dumb on my part. Yep, sorry. Yep. I was like, yeah. Yes. It was correct statement. All right, yeah. So first of all, yeah. No. All right, so a shout out to Guster for sponsoring Marco's travel this time. Also to Rhiannon and Justin for hosting Marco this time. All right, all right, all right. Yep. This should be Guster, Rhiannon, Justin. That would be correct. Yeah, so Guster, as you know, is sponsoring the meetup, and we use those funds to bring some speakers over. There's something else. So these are the sponsors of the conference, and we just confirmed a new one today. Yay! So if you want your company to be uploaded to, you know what to do. Now, those of you who are not on our Slack yet, please, by the way, can somebody try out this QR code to make sure it works? I just generated it on some free QR code generation website. I didn't actually download the image because it asked for sign up. So I just screenshotted it. There's another one. This QR code, it's another one. And this is something special. There's a new book, Human History of Ruby, a new upcoming book by Rhiannon up here. So she still says it's maybe, but we know it's coming. So if you want to see it, have this book see the light of the day, please use this QR code to just sign up and tell Rhiannon that you want to have this. All right, that's all updates from me. And now we'll go into the next open mic speaker, Camille.
Continue. Ta-da. Okay. So as Irina already said during the introduction part, we hosted a hackathon this weekend. It was in the Sentry office. Teams up to 3 people or solo, and it didn't cost anything. It was organized by myself, Dave, and Yatish, who bailed on me and sent me here to do this presentation. So shame on them, but I will do that. The goal was very simple: develop a Ruby project, and the theme was either use vibe coding, because everybody does so now, or implement generative AI under the hood. But it was optional. So if you just wanted to chill and do a simple Ruby app, whatever, you were able to do so without any problem. Results, 70 participants, engineers, but which I liked very much, also PMs who were able to use tools like Cursor, Cloud, and so on to build their own simple apps. One of the winners was actually a PM, not an engineer. So this was very, very fun, at least for me. 8 hours of hacking and playing pool as well. Thanks, Sentry. That was very fun. 10 a.m., 6 p.m., so a lot of work. 30 pitches and demos, so that was a lot of very interesting projects to watch and discuss. And we also had prizes, 3K total from our wonderful sponsors, Continue, Evil Martians, and Fly.io. Some photos, Irina already showed them, so I'm going to keep this brief. Like, this is the presentation part. And now to the winners. The first prize was collected by Josh with the project called VibeSec, and that was a very interesting app, basically a drum machine implemented in Rails. The second prize went to LLM Workbench by Jonty, and that was also it was basically a workflow execution engine with LLMs serving as the particular steps in the process. So you could have just put an agent as a step in the workflow. And the third prize went to Wheeltown. Oh, and by the way, the second project is the one created by a project manager. So that was very fun. Wheeltown, the third prize, that was related to keeping our streets safe for all the bikers who participate in the movement when it comes to. I think they were using AI to analyze photos when it comes to all of the different dangers that could be related to bikers and bikes in general. Here are the winners and the organizers, and myself, and also our wonderful judges. Two of them are here today. Justin, thank you for being a judge. Sarah, thank you for being a judge as well. Thank myself for also helping, because I also helped with the judging process, and Victoria as well. But she's not present today, right? Because I haven't seen her. We still some have free. Oh, it didn't update. Okay. We still have some free goodies left. So if anybody wants a free 1 month on Continue, use the code SFRuby25. This is for everybody here. Again, SFRuby25. And if anybody wants $50 of free credits from Fly.io, one of our sponsors, use this URL, fly.io/hello/fly with us, and you'll be able to claim your credits. And again, thank you for everybody who came. Some of you I already seen today. Thank you to all the judges. Thank you to the, and congratulations to the winners. And see you maybe next time. We'll see. Not soon, but maybe next time. Okay, thank you.
Okay. Hello. I did not prepare slides, so I guess you'll have to bear with me. My name is Andre Arco. You might know me on the internet as Indirect, the lead on the Bundler and Ruby Gems teams for the last 15 years or something like that. I am working on a new project to basically try and create a business out of being an open source maintainer and see if that makes open source maintenance possible. I am founding a Ruby open source maintainers cooperative, and what we will sell is retainers that let companies buy access to our advice and expertise without having to pay us extremely expensive salaries, and also without having to, pay us all the time. If you are a maintainer who is interested by the idea of joining a maintainers co-op and selling expertise to companies, I would love to talk to you. And if you are a company who wants to hire people who really, really know what they're doing with the tools that you sometimes need help using, I would also love to talk to you, because I have some really world-class maintainers who you could potentially get help and advice from. I am probably the easiest way to reach me is on Blue Sky. I am indirect.io, and on email, I am andre@arco.net. Great. Thanks.
Okay, hi. My name is Ratnadeep Deshmane. I do run a company called as Betacraft Technologies. We are a consulting company, a team of about 50 people. We do Ruby on Rails applications as well as all sorts of AI, Gen AI type of applications. Back in 2022 at RubyConf Houston, I had given a talk called as Writing Ruby, just not in English. That's behind now. I just wanted to present a quick idea about learning Ruby, just not in English. And the reason for this is, how many people here don't have English as their first language? Okay, not much. But if you look at the worldwide stats, 94% of the world's population do not have English as their first language. They have to learn English first, and then programming becomes accessible to them. Or even if they have learned programming, it becomes a bit of hard for them to truly get the sense of some of the words and the concepts and the ideas of the object-oriented programming, which is why I feel that it is also essential or important to have some introduction to the programming languages in your native language itself without having to rely on English. And that's what this idea is about. So this is a Ruby code written in Hindi, and all of it is a working code. Now, the benefit of this is the class is translated to a word called as Sancha. If you take any like anyone from, let's say, India who speaks Marathi or Hindi, the class is a word that is typically used in the context of classrooms, not in terms of class as in what is the original intention of the word class, like classification. So same thing happens with some of the other keywords as well. Okay, why def? And why some of the other keywords that we have in Ruby, right? So if you take an exercise where you're translating all of those keywords from English to your mother tongue, that becomes an exercise where you truly understand the meaning behind that. So by using this Ruby Vernac gem, you can create versions of it and be able to write the code in different languages. So here is an example in Hindi or Marathi. Then here is an example in Malayalam or Tamil. And here is an example which is written in Spanish. I don't understand what all is written in this code, but if you know Spanish, anyone here who understands Spanish? Yeah, okay. So this is also a working code. The benefit is also that when you write the programs in your different languages, you can write something that is very relevant and very good examples in that language, instead of relying on something like a foo bar, right, which does not have a meaning for a lot of people. And the fun part, there is also a gem called as Ruby Vernac emoji that I have created. With this, what you can do is write a program like this, which is all emojis. This is a valid Ruby code, and you can execute it. Yeah, you can write entire Ruby code as emojis, and it is executable code. Yeah. So over the this weekend SF Ruby hackathon, I got a chance to convert this idea from just a gem to a website, where my plan is to have a couple of languages supported, so that you go to choose whichever language that you want, and then have a very interactive exercise to learn the programming in a better way on the website itself. So I plan to support some of the languages that I understand, but I would be looking for help when it comes to the languages that I don't understand. So if you're interested in teaching programming, teaching Ruby, or anything in your own languages that you want to teach to some of the people, or if you know someone who could find this useful, let me know. I'm looking for help in terms of translations, in terms of getting this out, and having more people have access to programming in their own mother tongues. Thank you.
Okay. I'm Justin Bowen, and can anyone guess what I'm up here to talk about? Cats. Ruby LLM and cats. Yes, JRuby, cats. And ActiveAgent, which is a framework for building agents in Rails. You can use actions and views, maybe even Herb. Yeah, that said, I really like what Andre was just talking about, trying to make money off of open source. That'd be cool. I know most open source maintainers either have jobs at places like Shopify or do consulting. I actually am offering free consulting sessions if you want to pair and learn about ActiveAgent. But also, I think the lowest effort thing any of us can do is star your friends' repos. So go star Herb, go star the Vernac gem, yeah. And yeah, thank you. Oh, and star Ruby LLM too, why not?
No. Star Active Agent.
I think there seems to be a theme of people who want to write Ruby and get paid doing it. And I am going to keep the theme alive. All right. Heck yeah, I want to allow this to connect. No, not a keyboard. All right. So this is what I call my ultra remote portable workstation. I'm still drafting this article. And when it's done, I'll publish it. But I just thought I'd kind of share with you this thing I put together. Up here I have a laptop, a tripod, and then a Moonlander keyboard because, you know, who doesn't hike with their mechanical keyboard? Raise your hand. You should all hike with your mechanical keyboard. That's what it looks like up close. And let's see, this is my internet and my power, and of course, we have a battery right there. So what am I working on all day in the middle of nowhere, also known as Briones, which is about a 33-minute drive. If you ever come out to East Bay, check it out. It looks like the Windows XP background in the spring. It's not the real Windows XP background. You got to go north through that up in Napa. But the question is, what am I doing out there? I am working on a video course, Flex on Rails. So Marco spent a lot of time today talking about Flex, and I'm going to do a video course on it. So if you want to know more about how Flex works, go to beautifulruby.com. It redirects you to this page. And one thing I'm going to spend a lot of time on in this course is actually forms. So let's see if I can find the right browser tab here. Here we go. All right, has anybody used Superform? It is a form helper that all right, we have one person. It's a form helper that I rewrote from scratch from the ground up on top of components because if you've ever tried to style a select tag in Rails, it's not fun. Good luck styling an option, you can't do it, or it's very difficult to. So I built Superform, which is built on Flex, and that's something that I'm going to be spending a lot of time on because we're building a lot of forms in Rails, and this is just, I think, a better way of doing it. So I'm right now I have like 3 units on that, but it's probably going to end up being like 10 different videos and some pretty, I think, advanced use cases for it, including like bulk selection. There's been requests for has options. So I have a QR code up on the screen if you want to scan that on your phone. I do have low prices right now, $289, because the things, I'm still working on the videos, but when they're all done, I'm going to kick the price up to $379. So scan that if you want to check it out. And also along the way, I'm going to be sharing articles about how I hike outside and work on code. And I actually have a few outdoor workstations, so it'll be fun sharing that here. All right, that's it. Check it out, beautifulruby.com.
Hello. I'll try to screen share and see if this works. Oh, wow. Does that mean it is not working? Okay, that's okay. I can continue without it. Yeah. Oh, that's okay. I think I can just let's through this. This doesn't connect. That's fine. Yeah, I can actually just chat. So I've been experimenting with something that I made called agent-backed command, which uses a framework I wrote. The idea is that you can create a command for a domain that can operate the existing commands of the domain to kind of fill in a hole in the domain. And so I've been experimenting with that, and I just wanted to kind of share a couple of the more interesting things I came across. One thing that was really interesting is I used a demo loan origination domain. Something I found interesting was I had a find all loan files command and a review all loan files command and a review loan file command. And the review file loan, or the review loan file command was receiving a loan file. And I was worried because I don't know if the LLM might make a biased decision off of the applicant name, which is part of the loan file aggregate. So I created a different model called underwriter summary, and I only gave it the minimum amount of stuff it needed. And you can't see the code because I can't share my screen, but the only thing I had to do was change the input type of the review loan file command. I didn't have to change anything else. And actually, if I could show the slides, I was able to delete tons of domain logic as part of this process because I converted 6 out of about 20 commands to be backed by agents. Anyway, that gave me an interesting thought, which could be wrong or probably is wrong, but maybe there's a future where as engineers, or there's engineers that use an LLM to fill in gaps of their domain by operating the existing gaps in the domain. And then as the business scales and the domain becomes better understood, you go through and replace the automated parts of the domain with actual domain logic. I just found that interesting because it's backwards from where my intuition would have been like a month ago, which would be, let's find the parts of the domain we can automate. But this is, and going the other way, by the way, would speed things up and costs less per run, per execution, and can reduce inaccuracies if you actually know the domain, of course. What else was interesting? Another thing that was interesting was that in the Fubara agent, which is what the agent back command used, the algorithm is actually really simple. It's just until we've accomplished the mission, or we've given up, or we've been killed, determine the next command and inputs, the next command name and what inputs to pass to it, and just run that command with those inputs. You just repeat this in a loop, and that's all the agent is. So that was another thing that was interesting, was just how tiny the algorithm actually is. Was there anything else that was interesting? I did like benchmarks. It actually worked with QN3 32 billion. It almost worked with QN3 14B and 8B. It didn't work with GPT-4o, but it did work with 01 and 03. The best kind of seemed to be, well, the best seemed to be Claude 3.7. It was pretty fast. It only took about 2 minutes to underwrite 3 loans, which is kind of an eternity unless you're not in a rush, which you usually aren't when you're underwriting a loan. But anyway, sorry, lost my train of thought there. Anyway, it was kind of interesting. 3.7 was fast. It took about 2 minutes. The bigger, more expensive models took about 5 minutes. And yeah, I learned a whole bunch of other things. I guess I could share some of the info in Slack or whatever, but yeah, just wanted to share those quote unquote epiphanies. Thank you.
Miles, first of all, you have to share the slides on Slack. Second of all, that's for everybody. If you are on Linux, you're obligated to send me your slides from now on. And second of all, Miles, also a blog post, please. Yeah.
Will that work?
So you have to accept on your screen. If you plug your laptop back in, it's asking you what you want to share.
Here you go. Hey, so just shameless plug here. Roman's office hour. I started to do that at work. I don't know if you guys have that at your workplace or maybe like personally, but I found out that it's like super interesting to hear like people's problem and like try to help them to resolve them. And so, yeah, I wanted to share my experience. So, like, I heard like you can do that for pay. This is free, and I just wanted to like kind of like help people like solve their problem in Ruby and Rails. I've 12 years of experience with Rails. I've been working at Checker before, and then now Meraki, big monolith in Ruby and Rails. And I'd be really happy to take a stab at any problem that you have Maybe I'm not going to be able to solve them, but maybe I can be your rubber duck. So please add me on LinkedIn and contact me, and then we'll see where we can go with that. Thank you.
That's nice. So, Ronan, which step of Marcus' presentation are you going to be contributing to during your office hours? All right. So our next, now we have our next and final presentation for tonight. This is from Jeremy Evans from Ubicloud, the author. The author of Roda, SQL, polished Ruby programming book that we always recommend at Evil Martians to kind of mid-level Ruby engineers, maybe not for the newbies, but, and I just want to say this. It was the main idea from, at my RailsConf talk. The idea was that technology is not, it's my belief, the technology is not a single idea. The technology is actually what happens when multiple groups of people invest their time, invest their talent, invest their effort into building something up. And I think this is what we have in Ruby community. People like Jeremy investing their time, their effort into improving Ruby, improving the ecosystem. And we're gonna hear about that now. But think about this. No programming language is born perfect, and no framework is born perfect. It becomes great by decades of work that we all put into this. And Jeremy is a great example, and the talk we're gonna hear now is a great example of that.
Thank you very much. All right, well, hello everybody, thanks for staying. This presentation is going to be about code changes I made in Ruby 3.4 to eliminate unnecessary implicit allocations. My name is Jeremy Evans. I'm a Ruby committer. I focus on fixing bugs in Ruby and for the last couple of years also on reducing implicit allocations. I am the maintainer of SQL, Roda, Roth, and a bunch of other Ruby libraries. I live up in Sacramento, and thankfully I've been able to make it down here for the last few meetups. I work at Ubicloud as a principal software engineer. We are building an open source alternative to Amazon Web Services. Now, I'm going to start this presentation with a discussion on regressions, specifically allocation regressions. Now, an allocation regression is a case where Ruby unnecessarily allocates an object when it did not do so previously. And while working on reducing implicit allocations, in the span of about 2 weeks, I found and fixed 3 allocation regressions, all of which I caused. The first allocation regression involved this type of method call, which passes a positional splat, keyword splat, and block. When I started work on reducing implicit allocations, this allocated 1 array. And I made changes to the optimizer that made this call allocationless. And unfortunately, I found there was an evaluation order issue in this code. If keyword was not a hash and block was not a proc, the code would call block.toProc before keyword.toHash. Now, I fixed this before the release of Ruby 3.3, so this code will call keyword.toHash before block.toProc, and unfortunately, that broke the optimization. So in Ruby 3.3, this call still allocated an unnecessary array. Now, I fixed this allocation regression in Ruby 3.4, so this call is once again allocationless. The second allocation regression affected this code. Here we have a method that accepts a keyword argument, and we're calling the method with a keyword splat. And this should not require an allocation because we can just look into the keyword splat hash to get the value. And indeed, in Ruby 3.2, this call was allocationless. Now in Ruby 3.3, I fixed a bug that passed a keyword splat directly as a positional argument instead of passing a copy of the keyword splat if the method did not accept keywords. And unfortunately, that bug fix caused an allocation regression, resulting in this code allocating a hash. Now, I fixed this regression in Ruby 3.4, so this type of call is once again allocationless. The third allocation regression involved this type of call. So we have the same method that's in the previous example, but this time we're calling it the positional splat and static literal keywords. Now this allocates a single hash in Ruby 3.3. When adding an optimization early in the Ruby 3.4 development cycle, I introduced an allocation regression and made this call allocate an array as well as a hash. And the cause of the allocation regression was a mistake I made when refactoring a different optimization. So I added this argsplat no copy, optimized argsplat no copy function to reduce redundancy in 6 other allocation reduction optimizations that I made using the optimizer. And when refactoring the optimizer code to use this function, I passed the wrong instruction to the function. And this didn't cause any detectable problems, but it just meant that the optimizer could no longer recognize this as an optimizable case. Passing the correct instruction allowed the optimize argsplat no copy function to recognize this case, and that fixed the regression. So the code no longer allocated an unnecessary array. It still allocated a hash though, and I decided to see if that allocation could be eliminated. Unfortunately, Ruby's internal method calling API does not support literal keywords following a positional splat. So if you use literal keywords following a positional splat, Ruby will implicitly turn this into a keyword splat. And since a keyword splat requires a hash, using literal keywords after a positional splat generally requires a hash allocation. However, in this case, the hash needed does not depend on external code. All keys and values of the hash are immutable literals, and that allows you to pass a shared frozen hash instead of allocating a new hash. So this would be equivalent to having a constant storing the frozen hash, and then using that constant as the keyword splat hash. The only difference is that instead of a constant, this uses a frozen hash that is inlined into the virtual machine instructions. So let's look at the simplified virtual machine instructions for this method call in Ruby 3.3. The first 2 instructions create a new array and assign it to a local variable. These 2 instructions implement the positional splat. First, we get the value of the local variable, and then we use the splat array instruction to convert it to an array if it is not already an array. The false argument to the splat array instruction tells the instruction to not duplicate the object being splatted if it is already an array. So using this false argument to splat array is an optimization I added in Ruby 3.3 to avoid an array allocation for this type of method call. Now this is the instruction that sets up the keyword splat hash for the implicit keyword splat. And as you can guess by the dup hash instruction name, this duplicates an existing hash, which is what caused this method to allocate an unnecessary hash. To avoid the unnecessary hash allocation, we need to change the instruction to be put object. Now put object will push the hash onto the VM stack without copying it, and that's safe as long as the hash is frozen. Now the hash currently isn't frozen, so we're going to need to fix that when we implement the optimization. We're going to implement this optimization using the peephole optimizer. So the peephole optimizer is one of the optimization passes that Ruby has, and it goes through each of the VM instructions, looking for specific patterns in the current instruction and following instructions, and if it finds a pattern it recognizes, it modifies the instructions to use more optimized code. We're going to start the optimization by looking for splat array functions with false arguments. We only want this optimization to affect cases where the splat array false instruction is immediately followed by a dup hash instruction. We then check that the instruction after dup hash is send, and if so, that may be a case that we can optimize. In order to be optimized, it must have the following method call flags set. So argsplat means that the method call has a positional splat, keyword splat means the method call has a keyword splat, and keyword splat mute means the keyword splat is mutable. Additionally, for the optimization to be valid, the method must not be passing a block using an ampersand, so it cannot have the args block arg method call flag. Now, I omitted the method call flags when showing the virtual machine instructions, but here's what they are. So this tags the args splat, and keyword splat mute method call flag set, and it does not have the args block arg method call flag set. So this is a candidate for optimization. So this is the part of the code that implements the optimization. We first get access to the existing method call flags from the appropriate instruction object. We then check that the necessary method call flags are set, and the method call flags that are required not to be set are not set. And if so, all checks are successful, and we can proceed to the optimization. We change the dupe hash instruction to be a put object instruction. Now, the instruction output doesn't show it, but the dupe hash instruction argument is not a frozen hash. It's a hidden hash, but the hash is not frozen. And because the put object instruction must be frozen, as the same hash will be used for all calls, we make a copy of the existing hash using RB hash resurrect, and then freeze that hash with RB hash freeze. And obviously, a frozen object cannot be mutable, so the keyword splat mute keyword, method call flag is invalid. So we unset that method call flag, and that completes the optimization, and that means that this call is now allocationless in Ruby 3.4. As I mentioned, I found and fixed these 3 allocation regressions within about 2 weeks. And finding multiple allocation regressions in so short a time frame was disheartening. It indicated to me that there was little point in attempting to eliminate unnecessary allocations unless I could prevent future allocation regressions. So I thought about how to do that. And the conclusion I came to is that allocation regressions are no different in nature than any other regressions. And how do you protect against regressions generally? You add tests. Tests help you ensure expected behavior. If the expected behavior is a certain type of method call, allocates a certain number of objects, you need to write a test for that. And that way, if you change the code and it results in an allocation regression, the related test breaks, alerting you to the problem immediately and allowing you to fix it. So I started writing an allocation test suite. And as I have limited time, I'm not going to discuss the implementation of the allocation test suite, but I will go over a simplified example of an allocation test. In this allocation test, we define a method, and then we call the check allocations method. The third argument is the code that will be executed. The first argument is the number of arrays the code should allocate. And the second argument is the number of hashes the code should allocate. So this line tests that calling a method that has a single positional parameter with a single positional argument should not allocate an array or a hash. This line tests that calling the same method with a keyword splat does not allocate an array, but it does allocate 1 hash, and that's expected because the positional parameter should be a copy of the keyword splat hash. I think the allocation test suite that I created was my most important contribution to Ruby 3.4. It resulted in 3 major benefits. And the first benefit is, since its introduction, it has prevented further allocation regressions, at least for the cases that it tests. The second benefit was it allowed the Prism team to find all of the tested cases where the Prism compiler was allocating more objects than the parser Y compiler, and to fix all of those cases before Prism was made the default parser, and that prevented allocation regressions from the parser switch. And finally, the test suite shows for each call how many allocations the call was making. I could review the allocation numbers for a passing allocation test suite and find cases where Ruby was unnecessarily allocating objects. The allocation test suite basically provided me a list of call types where I could eliminate unnecessary implicit allocations. Note that not all unnecessary implicit allocations were in method calling. I found that large literal arrays can allocate more than 1 array. So for some background, I'm going to give a brief overview of the virtual machine instructions used to create literal arrays in Ruby. So the empty literal array allocates 1 array. This is implemented using a single VM instruction, new array 0. If the array contains only other frozen literals, such as numbers and symbols, it also only allocates 1 array. In this case, a hidden array is statically allocated for the literal, and the dupe array instruction is used, which returns a copy of that array. And this is true regardless of the size of the array, as long as all elements are frozen literals. Even if the literal array has 1,000,000 elements, it only allocates 1 array because a single dupe array instruction is still used, which returns a copy of the hidden array. Now in Ruby 3.3, if the literal array contains a non-frozen literal or an expression, the number of array allocations is based on the number of elements in the array. So here we have an array created with a single local variable. And this literal array will be created using 2 instructions. The first instruction will retrieve the value of the local variable and place it onto the VM stack. The second instruction will allocate a new array with a single element using the top element of the VM stack. Here's a more complex case. This is a literal array with 257 elements, all of which are local variable accesses. This is a case that actually allocates more than one array in Ruby 3.3. It allocates 3 arrays. So here are the VM instructions used. So the first 256 instructions just retrieve the local variable value and put it onto the VM stack. Then it creates one array with 256 elements. This is the first array allocation. And this instruction is the same as the earlier instructions and pushes the local variable value onto the VM stack. This new array instruction allocates another array to wrap that element, which is the second array allocation. And the final instruction is a concat array instruction, which takes the 2 temporary arrays and combines them and returns a newly allocated array. This is the third array allocation. I'm guessing a lot of you may be wondering, why Ruby allocates a new array for every 256 elements? It certainly wasn't obvious to me when I started looking at this code. And it turns out the reason Ruby does this is to avoid VM stack overflow. Now, the VM stack has a limited size. If you try to define a large enough little array, you could overflow the VM stack. And to avoid that, starting in Ruby 2.0, Ruby chunks large literal arrays into subarrays of 256 elements and then concatenates them together. If you try to create a literal array with 1 million local variable elements in Ruby 1.9, you get a system stack error. So this chunking in 256 elements seems reasonable, as you definitely want to avoid VM stack overflow. That being said, while this array allocation is necessary, since a literal array must allocate at least one array, these 2 array allocations seem unnecessary. Instead of allocating new arrays, we should be appending to the array that we allocated in the new array 256 instruction. And we can do that using a VM instruction I added near the start of the Ruby 3.4 development cycle, and added this instruction to reduce allocations in this type of method call. So the instructions for caller-side argument setup for this method call use the same 2 instructions, new array followed by concat array. And I eliminated both the array allocations using a new VM instruction called push to array, which pops the given number of elements off the VM stack and then pushes them into the array that's then at the top of the VM stack. And we can optimize literal arrays using the same push to array instruction. And that avoids both array allocations. And that means that this literal array only allocates a single array in Ruby 3.4. Turns out it's not just large literal arrays that allocated more than one array in Ruby 3.3. Literal arrays that contained positional splats also allocate more than one array in Ruby 3.3. For example, this literal array, which contains a single splat, allocates 4 arrays in Ruby 3.3. Here are the instructions used to create the literal array in Ruby 3.3. All 4 of these instructions allocate an array, even though only one array allocation is needed. Switching the final new array and concat array instructions to push to array eliminates 2 array allocations, and the final unnecessary allocation is due to this concat array instruction, which is used to implement the splat part of the literal array. And this is fixed by using another new VM instruction that I added to optimize method calls, which is called concat to array. So this instruction is similar to concat array, but it does not allocate a new array. And with these 2 changes, Ruby 3.4 now only allocates a single array when creating a literal array with splats. I think it's good that I was able to reuse VM instructions that I added to speed up method calls to also speed up literal arrays. However, I ran into a case that was not possible to optimize with existing instructions, and that case involved using keyword splats in literal arrays. So here's an example. We create a literal array using a splat of an array and a keyword splat of a hash. Ruby 3.3 allocates 3 arrays for this case. It uses the following simplified VM instructions for creating the literal array. This set of instructions is for the keyword splat, and these 3 instructions each allocate an array. This array allocation is needed because the literal array does need to allocate an array, but the array allocations for these instructions should be eliminated. Now, it's possible to save one array allocation by changing the concat array instruction to concat to array, which does not allocate a new array. However, then you would not be able to eliminate the array allocation in the new array keyword splat instruction, since concat to array can only combine arrays. And unfortunately, it's not possible to replace both of these instructions with a push to array instruction, because that will push an empty keyword hash onto the array if the keyword splat is empty. So the simplest solution to avoid the unnecessary array allocation was to add a new VM instruction with the expected semantics. That's what I did. So this instruction is named push to array keyword splat, and it's similar to push to array, but it does not accept an argument. So this instruction pops the top element off the VM stack and appends the popped object to the array currently at the top of the VM stack, unless the popped object is an empty hash. And with that change, literal arrays with keyword splats only allocate a single array in Ruby 3.4. Related to this, before I started work on this optimization, we received a bug report that Ruby's behavior in this case was actually incorrect. If you were keyword splatting an empty hash, and the keyword splat was directly after a positional splat with no elements in between, then Ruby 3.3 and below would include an empty hash in the array. Now, I submitted a pull request that fixed this bug in a backwards compatible way before working on the literal array optimizations. The push to array keyword splat instruction optimization also fixed this bug, and it was committed first. But my original pull request was backported to Ruby 3.2 and 3.3. So now Ruby 3.2 and above will no longer include an empty hash for an empty keyword splat in a literal array. And with these optimizations, I believe all literal arrays now only allocate a single array in Ruby 3.4. I'm not going to discuss how I eliminated caller-side unnecessary positional splat allocations. Now in Ruby 3.3, I was able to eliminate implicit array allocations for the following method calls by adding an optimization pass that changed splat array true to splat array false. And unfortunately, while the approach that I used of using the optimizer worked for these types of calls, it did not work for other types of calls. These calls all allocated an unnecessary array for the positional splat. All of these cases result in dynamic hashes after the positional splat, which is not one of the cases that the optimizer can optimize, because the instructions for creating dynamic hashes are not fixed. Optimizing these cases requires knowledge of the parse tree, not just access to the unoptimized instructions, and that meant to optimize these cases, I would have to move the optimization from the optimizer to the compiler. So I looked into how to optimize these cases in the compiler. Now at the time, the default parser was parse y, and the main function for compiling arguments for method calls when using parse y is named setupargs core. Now the fourth argument is whether you should duplicate an array being splatted. And this is what controls whether the method call allocates an array for the splat. My first thought to optimize these cases was to look for places where we're passing non-zero for the dupressed argument and see if we can change it to pass 0 while still complying with Ruby semantics. One case I found is this recursive call inside setupargs core. So this case happens when compiling an args push node. And the args push node is used in Ruby when you have arguments following a positional splat. So here are all examples of calls that would use an args push node. This type of method call with a positional argument after a positional splat needs to allocate an array, because Ruby's internal method call API does not handle positional arguments after a positional splat. So an array needs to be allocated for the splat, and the argument following the array needs to be appended to that array. These four method calls do not need to allocate an array because there was only a positional splat and no positional arguments following the splat. These two cases were previously optimized by the optimizer in Ruby 3.3. So the compiler would create instructions that allocated an array, but the optimizer would recognize those instruction combinations and change them to not allocate an array. These are two cases that unnecessarily allocated an array in Ruby 3.3 because the optimizer only handled cases where static keywords or a single keyword splat were used. Now here we are calling setupargs core with a non-zero value, forcing array allocations for splats in this recursive call, even though array allocations may not always be necessary. Now it turns out in some cases we can know before the recursive call that it is safe to avoid the array allocation. By replacing those two lines with this code, I was able to optimize more cases. So let me go over what this new code does. First, realize that this code is the same as the previous code, just split into an additional if statement. This is the new code being added. The first condition for the optimization is the head of the args push node is a splat node. And that's true in all of these cases because the first argument to the method call is a positional splat. The second condition is the body of the args push node is a hash node. That's also true in all these cases because literal hashes, literal keywords, and keyword splats are all parsed as hash nodes. And the final condition is that ND brace is not set. So ND brace is set on hash nodes for literal hashes, but it's not set on hash nodes for literal keywords or keyword splats. So this affects the bottom 4 cases, all of which use literal keywords and or keyword splats and do not need to allocate an array, but not the top case, which uses literal hash and does need to allocate. If all 3 of these conditions are true, then the recursive call to set up args core is set to not allocate an array for the splat, and that eliminated the array allocation for these types of calls. Unfortunately, Ruby would still allocate an array for these calls. And that's because these calls use a different parse tree. I'm actually going to choose these 2 calls to show the difference. And the only difference between these 2 calls is the bottom call has an argument before the positional splat. So here's the simplified parse tree for both of these calls. The difference between the parse trees is without a leading argument, a splat node is used. But with a leading argument, an args cat node is used. Args cat node compilation had similar code to the args push node compilation in that it told recursive calls to allocate a new array. However, the same optimization could not be safely applied to the args cat node because args cat is also used for method calls with multiple positional splats. To properly optimize, you would need to compile these 2 args cat nodes differently. You would want this args cat node to not allocate an array because only a single positional splat is used, but you would want this args cat node to allocate an array since there are multiple positional splats. I couldn't see how that was possible with the setup args core API. So I changed the API. Instead of taking an integer for whether the current node you are compiling should allocate an array for the splat, I changed the argument to be a pointer to unsigned in. And this allows for tracking this information in a single place across recursive calls to set up args core. For the args push node compilation, which I previously changed to this, I was able to take all the code I added and delete it. And as I was no longer defining this variable, I just had to pass the existing pointer directly. Now here's a case where the dupe rest argument was used to make a decision about whether to allocate an array for the splat. So this adds the splat array instruction, and the argument to the splat array instruction is whether to allocate an array for the splat. Now that dupe rest is a pointer and not an integer, we need to change this to dereference the pointer. And this code previously set that the positional splat was mutable if we were allocating a new array. That code was eliminated from this branch and other similar branches, and it was moved to a centralized location to ensure that we never allocate more than 1 array per method call. If we did allocate an array for the splat array argument, we set the dupe rest flag to 0 so that no more arrays will be allocated. And to avoid unnecessary allocations, we decide whether to allocate an array for a positional splat before the call to set up args core. We default to not allocating an array, and if we are sure an array allocation is not needed, then we set the call to not allocate an array. Now this is pseudocode because it takes a significant amount of work to determine whether it is safe to avoid allocation. Now there are 4 parse tree cases where we can avoid allocating an array. The first case is where the only argument is a positional splat. The primary argument node in this case is a splat node. If the primary argument node is a splat node, it's always safe to avoid allocation. The second case is when there are 1 or more positional arguments followed by a positional splat. In this case, the primary argument node is an args cat node, and the head of the args cat node is a list node. So the code checks that the primary argument node is an args cat node, and if the head of the args cat node is a list node, then it's safe to avoid allocation. The third case is when there is a positional splat followed by literal keywords or a keyword splat. Parse tree for this case has args push as the primary argument node, with head being a splat node, and the body being a hash node that is a keyword argument. And the third and fourth cases are related. So I'll discuss the fourth case at the same time. That's when you have 1 or more positional arguments followed by a positional splat, and then followed by literal keywords or a keyword splat. So in the fourth case, instead of a splat node, we have an args cat node where the head is a list node. So the code first checks that the primary argument node is an args push node, and if so, it checks whether the head of that node is a splat node, or the head is the args cat node, or the head of that is a list node. And finally, code checks whether the body of the args push node is a hash node where ND brace is not set. So with those 4 cases handled, I was able to avoid array allocation for all cases where a single positional splat and no post-splat positional arguments are used. Unfortunately, this broke tests because it's not actually safe to eliminate the allocation for all such calls. For example, if keyword is a local variable, then it's safe to avoid allocation. But if keyword is a method call, it's not safe because the method could modify the array being splatted, and that is an evaluation order issue. In order to be safe, you need to inspect all subnodes of the hash node and determine whether any of those nodes contains an expression that could cause an evaluation order issue. So I added a function that could be passed a node and will return true if the node could potentially modify an existing argument splat. And this will allow local and instance variables, most literals, as well as most constant references. This line handles nested constants, which may not be safe. For example, this type of nested constant reference, where all parts are constant references, is safe enough to avoid allocating an array for the splat. However, this type of constant reference, which looks for a constant under a module returned by a method call, is not safe because the method call could modify the argument being splatted. And with that function defined, the remaining step is to check all of the key and value nodes for literal keywords as well as the nodes for keyword splats. So I added this code. We start with the hash node for literal keywords and or keyword splats. All keys and values of literal keywords as well as keyword splats will be inside this hash node. Each entry in this hash node is either a key value pair or it's a keyword splat. So we're going to iterate over all of them. The head of the node is the key node for a literal keyword, or it's null for a keyword splat. So if the key node is set, we call the function to determine whether the node is safe. If it's not safe, we mark that we need to allocate an array for the splat, and then we stop processing. If it is safe, we move to the next node. And then we get the head node for that, which is either the value node for a literal keyword or the node for the keyword splat expression. We do the same check that we did for the key node, and we handle unsafe nodes the same way, and we repeat this process for every keyword or keyword splat in the method call. It turns out that in addition to checking the keyword arguments, if a block is passed via an ampersand, you also need to check the block pass expression. So here's the code for that. First, if we already know we're going to duplicate the array anyway, we don't need to check the block pass expression. We only want to do this check if a block pass expression is provided. And we do the same check on the block pass expression that we did on the keywords. And if the block pass expression is not safe, then we must duplicate the array being splatted. And with that change, all cases that unnecessarily allocated a caller-side array in Ruby 3.4, or in Ruby 3.3, no longer do so in Ruby 3.4. Additionally, I was able to remove the entire optimizer change I added in Ruby 3.3 because this compiler change handled all of the cases that the optimizer handled, as well as all these additional cases. Now, a while after making that optimization, I found a related evaluation order issue in this type of method call. Here we are keyword splatting a variable. And since this is a single keyword splat without literal keywords, it would generally not be duplicated. However, in the same method call, we are mutating the variable in the block pass expression. If we don't duplicate the keyword splat expression, then this is an evaluation order issue because the deleted key will not appear as a keyword argument. To fix this evaluation order issue, we go back to the setup args code. We were previously only using 0 or 1 values for duprest, but now we want duprest to track 2 types of information. The first type of information is whether a positional splat should be duplicated, and the second type of information is whether the keyword splat hash for a single keyword splat should be duplicated. Now, in order to do that, I created macros for these 2 conditions. Splat array true is used for the condition where we need to duplicate the splat array, and dupe single keyword splat is used for the condition where we need to duplicate the keyword splat hash. Note that we want to set dupe single keyword splat even if we're already going to be duplicating the splat array, so we need to remove that condition. And now that we've set that flag, we need to change the keyword compilation code to use it. So this is what the code looked like before the change. If the keyword splat node was not a single keyword splat, we would mark the method as containing a mutable keyword, and then we call compile hash with the keyword node, which may be literal keywords and or 1 or more keyword splats. And here's the code I added to fix the evaluation order issue. These sections are the same as the previous code, split into 2 parts. This is the new code. So if the keyword node is a single keyword splat and the dupe single keyword splat flag is set, we we call a new function designed only to compile single keyword splats, where we need to duplicate the keyword splat hash to avoid the evaluation order issue. And here's the definition of that function. First, since we'll be allocating a new hash for the keyword splat, we mark the method as passing a mutable keyword splat. This is the same compile hash call that we had previously. This will compile the keyword splat node without duplicating it. These instructions create a new empty hash before evaluating the keyword splat expression, and then merge the keyword splat hash into the new hash. In other words, this is the code that's duplicating the keyword splat hash. And with that change, the code no longer had an evaluation order issue, as it now duplicates the keyword splat hash before calling delete on it. Now, one negative aspect of fixing this evaluation order issue is that it's pessimistic. Let's say you have a method call like this, where the block argument is itself a method call. Now, in your class, it's a simple @reader method. So you know it's safe to avoid allocation, because the block method will never modify the keyword splat hash. Unfortunately, Ruby will always duplicate the keyword splat hash in this case. That's because when compiling the method call, Ruby only knows it's a method call. It doesn't know what type of method call or how the method is implemented. Even if it did know that information, it wouldn't be safe to use instructions that eliminated the duplication of the keyword splat hash, because at any point the method could be redefined to modify the keyword splat hash. I thought it would be useful to issue a performance warning in this case, letting the user know that this code was implicitly allocating an unnecessary hash, and encouraging them to store the result in a local variable. And with that local variable set, block in the method call is a local variable reference and not a method call. So it cannot cause an evaluation order issue, and therefore the method call instructions do not need to duplicate the keyword splat hash, which saves a hash allocation. Now, I submitted a pull request and redmine ticket for this performance warning. This performance warning found a method call with an unnecessary allocation in SQL, found a method call with an unnecessary allocation in RubyGems, found method calls with unnecessary allocations in a couple of standard libraries, PP and opparse, found 5 method calls with unnecessary allocations in Rails. Unfortunately, Mats was not in favor of this idea. Admittedly, the performance warning was complex, and there were relatively few method call sites that were affected by it. I mentioned that this found 5 method calls with unnecessary allocations in Rails, and one of those turns out to be a case that probably should have been optimized. And here's what that method call looks like. In this method call, there was an array allocated for the positional splat. And the reason for this is the via keyword argument uses a literal array. And even though all elements of this literal array are themselves safe, the code I showed earlier to check whether arguments were safe did not include support for literal arrays. Let's take another look at that code. So this supports a number of nodes, but unfortunately it doesn't support the node used for literal arrays, which is node list. So I decided to add support for this. And here's what that support looks like. Node list is implemented as a linked list. Each node list has an ND head pointer for the node for the current element in the array, as well as an ND next pointer for the node list for the next element in the array. So we iterate over each element in the list, and for each element we do a recursive function call to see whether that node is safe. If the node is not safe, we return true, and if we get through the whole array and all elements are safe, then we return false. And that fixes the Rails method call to not allocate an unnecessary array for the positional splat. My challenge to you, the people that remain here at least, is to expand the node types that are considered safe. A good place to start would be to implement support for node hash, so that literal hashes would not cause unnecessary allocation, as long as all elements of the hash are themselves safe. There are likely a number of additional node types that are also safe. I'd like to finish up this presentation by discussing the remaining implicit allocations and method calls and whether they could be fixed. Let me just start with caller-side implicit allocations. First, having arguments after a positional splat or having multiple positional splats. Ruby's internal method calling API only supports a single positional splat and does not support arguments after it. So in both of the cases, the caller needs to allocate an array for the positional splat and combine all of the extra arguments into this array. And that's not fixable without major internal changes. Second, having literal keywords in a keyword splat or having multiple keyword splats. Again, Ruby's internal method calling API does not support this. It only supports only literal keywords or only a keyword splat hash. So in both of these cases, the caller must allocate a hash and then merge all this into one hash. And this is also not fixable without major internal changes. Finally, a positional splat followed by non-static literal keywords. This currently allocates a hash, even though it doesn't really need to, because Ruby's internal method calling API does not support both a positional splat and literal keywords, only a positional splat and a keyword splat. So this internally converts the literal keywords to a keyword splat. I think this case is much easier to fix than the other two cases, though still fairly difficult. Now let me discuss callee side implicit allocations. First, having a named positional splat parameter requires array allocation. I think this allocation is unavoidable in the general case until we have a generic de-optimization framework, because any method call could result in an eval or access to the binding. Second, a named keyword splat parameter requires hash allocation. I think this allocation is unavoidable for the same reason. And finally, calling a method that only accepts positional arguments with literal keywords or a keyword splat. The callee automatically converts the keywords to a hash. And I think this allocation is also unavoidable for the same reason. I hope you had fun learning about a few of the allocation reduction optimizations that are in Ruby 3.4. If you enjoyed this presentation and want to read more of my thoughts on Ruby programming, please consider picking up a copy of Polished Ruby Programming. And that concludes my presentation. I'd like to thank all of you for listening to me. Questions? Anybody, questions?
What is the book about?
What?
What is your book about? Your book?
My book is my book talks about sort of the trade-offs you make when you're doing Ruby code, and it's in general not really prescriptive. There's a few things it tells you to avoid, like don't use class variables, don't use Rubocop's metrics, or enforcing Rubocop metrics. But in general, it basically tells you like there's different ways to do things. These are the trade-offs you're making, and basically how you can, what you should consider when you're designing code, when you're making trade-offs. Like it'll tell you like this is the advantage of doing this way, this is the advantage of doing that the other way, and it'll help you make more informed choices when you're sort of designing Ruby code. It's not designed for beginners. It's designed for intermediate to advanced Ruby programmers. It assumes you already knew Ruby fairly well.
Yeah, when you were adding your new ability to test allocations, were there other tests like timing tests and memory and things, or was it just very clear that allocation is always bad, there's never a downside to it? What other kind of testing did you do?
I would say that this came out of sort of more out of purity than of practicality or pragmatism. One of the things I was working on when I started working on this was the idea that Ruby should never allocate an object unless it needs to. So that was the underlying goal, is to eliminate all unnecessary allocations, even those that probably don't affect code. I mean, a lot of what I showed here is unlikely to affect most production code. I mean, it helps in some micro benchmarks, but a lot of the method calls that I optimize in Ruby 3.4 are the less common method calls. Most of the more common method calls I optimize in Ruby 3.3 to avoid allocations. So this is sort of the remaining work. Pretty much all the low-hanging fruit is now gone. Anything else is going to require a significant amount of work. There were actually numerous other allocation reduction optimizations that I didn't talk about that were made in 3.2, in 3.4. A couple of those were using the fact that keyword splats can, nil is accepted as a keyword splat value. So it used to be you couldn't keyword splat nil. But now that you can keyword splat nil, you can actually pass nil instead of a hash when you want to sort of have an implicit empty keyword splat value, and that saves an allocation. And then in Ruby 3.5, some work I did was doing the same thing for arrays. So previously, nil.2a worked for converting nil to an empty array, but it always returned a new array. So previously, if you had nil as a keyword splat value, you'd have to you would always be allocating an array. And we're changing this in the Ruby 3.5 based on sort of consistency with how keyword splats are handled. So that if you do a positional splat on nil, it does not allocate an array. So that's one of the only things I worked on for allocation reduction-wise, and that'll be in Ruby 3.5.
No, can I ask one first? Jeremy, what's your, I'll go there. What's your kind of vision for Ruby moving forward? I guess a bunch of people are interested in, hey, can we make Ruby, okay, quote unquote, closer to Go in performance from the performance perspective? But
I don't work, I mean, I've been working on these reduction optimizations. Most of what I worked on previous to this was bug fixes. I was going through the bug tracker and fixing a lot of older Ruby bugs. So I don't really have a vision or have like a big feature set. A lot of the other Ruby committers, I said the vast majority of Ruby committers have one thing that they're focused on. One person working on the parser, a bunch of people working on JIT, people working on other things, but I've never really had a focus on a particular part. It's really mostly been going through the bug tracker and then going through and fixing various aspects of Ruby, but no underlying sort of focal point in my development in Ruby core.
It's not a question. I just want to say thank you for sweating all these details. I just write all this beautiful Ruby, and it just runs faster thanks to you and the maintainers of Ruby. I do have one question though. I saw a lot of just method calls that you were involved in, and I've always kind of wondered, will we get something like Elixir pattern matching or method overloading or whatchamacallit in the other languages?
Pattern matching we already kind of have, and it's been there since 2.7, so it's not all that optimized, but as long as you don't care about performance, it works pretty well. It does make code nicer. I mean, if you've done pattern matching, it does make things nicer. So the vast majority of what we work on is not performance sensitive in most cases. I mean, some of the libraries I work on, I focus on more on performance, but in general application code, unless you're in a hot path, you don't need to worry about like how fast your pattern matching is. In terms of like method overloading, where you have one method or you have method with the same name that's called based on the arguments it's passed, I don't think we'll ever get that in Ruby. It's just not built into the language, and there's been no proposals even in that area as far as I'm aware. So Ruby's flexible enough that you can emulate it. You can obviously have your method accept pretty much any combination of arguments and expect the arguments you're given, and then do dispatching to different methods. So it's possible to implement method overloading in Ruby, but you have to sort of do it manually. It's not built into the language.
Yeah, that's how I've done it. I do look forward to your future talk on HereDocs. You have a question?
Hey, so I think you said it was from Ruby 3.2 to 3.3 that you fixed a bug where if you passed a keyword splat to an array literal, that it would previously give you an array with an empty hash.
Yes.
Whereas now it'll give you an array with nothing.
Yeah.
Why is that correct? Because I would expect if there's something in there, you have the hash with the something in there. So if there's nothing in there, the empty hash should stay there.
No. So it's in Ruby, if you keyword splat an empty hash, it's considered the same as not keyword spotting anything. That's one of the changes that was made in Ruby 3.0. In the keyword argument separation in Ruby 3.0, and even this goes back into like even to 2.7. We made a decision that keyword splats that are empty should be treated as not passing any arguments at all. Because previously in like Ruby 2.6 and below, often like if you passed a keyword splat in a method call, it would pass an empty hash. But that we couldn't get keyword argument separation to work that way. We had to make it so if you keyword splatted an empty hash, it was like passing not keyword splatting at all. It was basically ignored. And to be consistent, that has to be done everywhere because we want the language to be consistent. So it happens in literal ways as well as in method calls. So if like, for example, if you have a method that accepts a positional splat and you call it with an empty keyword splat, you got an empty array. You don't get an array with just one hash. That's how it's worked since Ruby 2.7. So this is basically a way to make literal arrays consistent with how keyword splats are handled in method calls. And the correct behavior was already done by default. This bug only happened if you were keyword splatting directly after a positional splat. That was the only case where it actually happened. If you keyword splatted without a positional splat, then it did not have the hash allocations. This was definitely a bug fix and not like some new feature.
Folks, if anybody can ask a question, reciting another example from Jeremy's talk, a bigger, a larger one, then you get a merch from me.
Hey, Jeremy. I'm just curious, on the work you've done with memory allocation bugs, have you come across any like overlap with garbage collection issues in Ruby?
Overlap with what?
Garbage collection. So like cleanup of the memory allocation.
Not in this case. So like if you allocate an object in Ruby, it doesn't end up being, it ends up just basically being more work. You want to avoid allocations not because it has any memory issues, because the garbage collector cleans up after it, but the garbage collector in Ruby is not incredibly fast at allocating objects. It's actually fairly slow. If like you're not doing a lot and you're allocating an object, that object allocation is going to significantly slow what you're doing down. Now, if you're doing something that's performance intensive, I mean, the single object allocation is not going to be much relative to that. But relative to not doing anything at all, it's actually quite a bit of work. I think if you were here last month for Charles's talk, and he talks about the JRuby garbage collector, the Java garbage collector, and it's like 10 times faster at allocating objects than Ruby, in which case you probably don't need to care too much. Like, who cares if it's allocating objects, because that's not slow. But in Ruby, it's actually fairly slow, and you want to avoid it when you can. In my experience, if you have like slow code that's not like obviously slow due to some sort of algorithm issue, eliminating unnecessary allocations is one of the fastest ways to speed things up.
Hi, Jeremy. In your talk, you mentioned that we combined like 2 VM instructions to create a new VM instruction, the push to array one. I had sort of like 2 questions. One, did you face any reservations from other core Ruby committers for introducing new VM instructions? And if not, is there an opportunity for us to figure out more such patterns where we could combine a couple of VM instructions into a new one, and that way reduce the overall?
So the instructions are sort of built into the virtual machine, so you can't just like add them willy-nilly. I mean, every instruction I added, it's not just like, when I say I added it, it's not like I added it by myself. It's something that I proposed it, and then usually Koichi, who's the virtual machine author, he's usually the one to review any new instructions and make sure they make sense. In all of the cases, these new instructions significantly reduced allocations. And for the push to array keyword splat instruction, that more or less replaced the existing new array keyword splat instruction. So it, by itself, it probably wouldn't have been worth adding, but since it was just replacing an existing instruction and it was more optimized, there wasn't any issue with it. For the other 2 instructions that were added were push to array and concat to array. And those sort of were added on top of all the existing instructions, not replacing existing instructions. But they were beneficial enough in multiple areas, first in method calling and then later in for literal array. So they ended up, definitely being helpful enough to be included. But in general, you don't want to just add virtual machine instructions for every possible use. You want virtual machine instructions that are generic enough that you can use them in a wide variety of cases.
Hi, so when you were discussing making the optimizations on the parser side, did the move from parse.y to Prism enable a lot of those types of optimizations? And B, when you mentioned JRuby, would other implementations that use Prism also benefit automatically from those optimizations?
Yeah, so it's a good question. So JRuby would be different. Pretty much all this work in CRuby is done in C. So JRuby has their own compiler and stuff. So this would not affect anything JRuby is doing. In terms of would Prism make this easier? No. And the reason is Ruby supports both Prism and parse-y. So now we have twice as much work. If I want to make a change, like I discussed here, adding support, I showed the parse-y code because that's sort of what the whole presentation was about. But I had to make the same exact change, or not the same exact change. I had to make a related change using the Prism's API to the Prism compiler. So it's basically we have two compilers in Ruby now, and doing any work in the compiler is basically twice as much work as it used to be. Because now you have to do it both in Prism and in parse-y. And that's going to be true as long as Ruby supports both. I know people think that Prism is the future, and Mats has already basically said that the Prism API is what Ruby will be using going forward. But that does not necessarily mean that it'll be the Prism implementation going forward. It just means the Prism API will be going forward. There are more people in Ruby core working on parse-y than there are working on Prism. So it is possible if Prism, or if the parse-y team is able to emulate the Prism API, it's possible that we'll go back to parse-y at some point. I'm not saying it's definite, but until Ruby sort of chooses only one parser, it could be either going forward. There's not like, nothing has been like written in stone yet.
Nice. All right, let's give another round of applause to Jeremy.
And thank you very much, Irina.
Yeah, and again, to all of you, thank you so much for coming. We should definitely leave before 9. That's what I promised. So we stayed a bit later, but thank you for all of your questions. I think they were great. And yeah, the next meetup is at GitHub in August. Check out luma/sfruby as always, and we'll see you there. Thank you.